Question number 1. The frequency of radiation emitted when the electron falls from n is equal to 4 to n is equal to 1 in a hydrogen atom will be, given that the ionization energy of hydrogen is 2.18 into 10 raised to minus 18 joules per atom, and H is equal to, that is a Planck constant, is equal to 6.625 into 10 raised to 34 joules per second. Well, when we take into this consideration, let's start with a formula, that is the change in the energy. So change in the energy is equal to, with respect to the ionization energy, into, now the transition over here is from n1 square minus 1 over n2 square. Okay, now let's first try to get the difference in the energy. Therefore, as we have been given with the data that n1 is equal to 1 and n2 is equal to 4, right? So therefore, let's substitute the values as the change in the energy is equal to ionization energy, that is going to be as 2.18. So 2.18 into 10 raised to minus 18, right? The whole thing divided by 1 over n1 square minus 1 over 4 square. So because our transition is from the fourth, correct? So therefore, it becomes 16. Now, let's have this answer over here. Delta E is equal to ionization energy 2.18 into 10 raised to minus 18. The whole thing. Over here, we'll take our first LCMs. So we are going to get over here as 16. So 16 minus 1, we will get over here as 15. Thus, we can write it down as the change in the energy is equal to, when we are going to have this particular value, it would turn out to be around 2.04. Okay, to be much more precise, it will be around it is going to be 2.043 into 10 raised to minus 18. Okay. So 10 raised to minus 18. Right? So let's keep this particular thing aside. Let's have this particular thing aside over here. Now, from the another expression, as what we have is delta E is equal to H nu. Now, why am I going to take this particular expression is because nu is nothing more than the frequency which we are trying to calculate it for. So thus, let's have nu over here is equal to, frequency is equal to change in the energy divided by the Planck's constant. So therefore, that is nothing more than 2.043 into 10 raised to minus 18, the whole thing divided by 6.626. Okay, so here 626 into 10 raised to minus 34. Now, once we substitute all these particular values, we would have it as, upon the calculation, we would end up getting over here the answer as 0.38. Okay, so around 0.308 into 10 raised to minus, okay, it is, sorry, I'm going to be sorry for this, it is going to be 16. Okay, 16 per second. So if we just shift up this particular decimal, frequency is going to be equal to 3.08 into 10 raised to 15 per second as the answer. So therefore, our answer over here is B, that is 3.08 into 10 raised to 15 per second.